I welcome you to Kenya Co Mathematics Classroom. And on this particular episode, we are still looking at binomial expansion. And this is the part two of the binomial expansion or the binomial theorem. When we started with the binomial theorem, we were looking at the binomial expansion in general, how to expand binomials. We also look at the Pascal triangle, how to generate the coefficient, how to use the constant coefficient to do expansion. But we said that when the exponent becomes large, then the expansion becomes tedious. And that is why we are going to introduce the binomial theorem. But I want you to take note of these two formulas. We have a plus x exponent n. This is the same as a exponent n plus na. Then we have n minus 1 x plus we have n minus 1. Then we have a n minus 2 over 2 factorial. Then we have n minus 1. You have n minus 2 over 3 factorial. You have a n minus 3 x cubed. Okay, so here we have x squared also here. Then up to x exponent n. So take note of this. A plus x exponent n is the same as a exponent n plus na exponent n minus 1 x plus n minus 1 a exponent n minus 2 x squared over 2 factorial plus n minus 1 n minus 2 a exponent n minus 3 x cubed over 3 factorial up to x exponent n. And we use this when n, we use this formula when n is a definite positive integer. Definite positive integer. When we talk about integers are positive or negative or whole numbers. And so when the n is a definite positive integer, this is the expansion that you are going to use. Now, we also have the expansion 1 plus x exponent n, and this is 1 plus nx plus n. You have n minus 1 over 2 factorial x squared. Then we have plus n, we have n minus 1, we have n minus 2 over 3 factorial s cubed up to a term in x exponent n. So we also use this. Now, when the n is a definite positive integer, then we use this expansion, this formula or this theorem. But when n is not a definite positive integer, then we can use this one to expand. Now, when you use this one, you will get the same thing as using the Pascal triangle coefficient or the coefficient of the Pascal triangle to also expand. But this will make it simple because when the exponent becomes very large, it's better to use these formulas. Now, in our next presentation, we'll be looking at the combination approach. But for now, these are the two that we are going to use. So take note, a plus x exponent n is equal to what you see there. And the way you use this when the n is a definite positive integer. But when the n is not a definite positive integer, that is, it can be half. Then we use the expansion 1 plus x exponent n. And this is equal to 1 plus nx plus n minus 1 over 2 factorial s squared plus n minus 1 n minus 2 s cubed plus up to that. Don't forget that it's over 3 factorial. Now, with the 2 factorial, 3 factorial thing you are talking about, in general, when we say r factorial, this is r times r minus 1 times r minus 2 times r minus 3 up to 3 times 2 times 1. What do we mean by this? This is very simple. When we say 2 factorial, it's the same as 2 times 1. You multiply from the number until you get to 1. And 2 times 1 is 2. So 2 factorial is 2. When we say 3 factorial, this is 3 times 2 times 1. 3 times 2 is 6. 6 times 1 is 6. So we have 6. When we say 4 factorial, this is 4 times 3 times 2 times 1. And 4 times 3 is 12. 12 times 2 is 24. 24 times 1 is 24. I guess by now you can see the trend. Now, when we say 5 factorial, it's multiplying from 5 times 4 times 3 times 2 till you get to 1. And 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. 120 times 1 is 120. So you can continue in that order. So in general, when we talk about factorial, this is what you're talking about. So if you are 2 factorial, it's 2 times 1. If you are 3 factorial, it's 3 times 2 times 1. If you are 4 factorial, it's 4 times 3 times 2 times 1. If you are 5 factorial, it's 5 times 4 times 3 times 2 times 1. So if you also have 6 factorial, then it's also going to be 6 times 5 times 4 times 3 times 2 times 1. You also get your answer. So in general, that is what we are talking about. And we are going to look at how best we can use these formulas or these theorems to solve for binomial expansions, And so let me get this formula off. Now, let's assume that this is what we are given. Let's assume that we want to see how best we can apply the first one. Assuming that you are asked to expand, you have 2 plus x exponent 4. If you have to expand this, take note that this one is the same as multiplying this by itself. That is 2 plus x times 2 plus x times 2 plus x times 2 plus x. And this is very tedious. And even if you want to use the constant coefficient of the fourth exponent, that would be 1, 4, 6, 4, 1. And I guess you know why is this. Now, if you want to use the constant coefficient, it's also tedious. But if you are trying to use, don't forget that this is a definite positive integer. So that's why you are going to use this formula. So when you compare this to this, realize that a is 2, x is still your x, but n is now 4. So you can see that a is equal to 2. The x is still the x there in the formula, but the n now is equal to 4. That means when you go back to the formula, wherever you see a, you now put your 2 there. X is still x, but n is now 4. So this 2 plus x exponent 4 will be equal to, it is a exponent n, and a is now 2. So you have 2 exponent n, that is 4. Then plus n is 4. So you have 4. Then you have a, and a is 2. Then you have exponent n minus 1. And that is 4 minus 1 x. Then plus you have n, and n is 4. Then you have n minus 1, so 4 minus 1. Then you have a exponent n minus 2, and a is 2. So 2 exponent n minus 2, and n is 4. So you have 4 minus 2. You have s squared, and this will be over 2 factorial. Then plus you have n, that is n is 4. So n minus 1 will be 4 minus 1. N minus 2 will be 4 minus 2 over 3 factorial. Then you have a. And don't forget that a is 2. So you have 2 exponents n minus 3. And n is 4. So you have 4 minus 3 s cubed. We are not done yet. So it's plus. The next one will be 4. 4 minus 1. The next one will be 4 minus 2. Then the next one will be 4 minus 3. Then you have 2 raised to the power 4 minus, this will be, instead of 4 minus 3, the next one will be 4 minus 4. Then you have x raised to the power 4. Also all by 4 factorial. So don't forget that the formula we ended at 3 factorial. But if you want to continue, then it will now be n minus 1, n minus 2, then n minus 3. That's how come we have the 4 minus 3. Then over 3 factorial. But this one will be 4 factorial because it's the next term. So assuming that it was 2 plus s exponent 5, that means we have to continue with the same trend. And so that is that. Now we simplify. And 2 raised to the power 4, this will give us 16 here. Then we have plus. Now 4 minus 1 is 3. 2 raised to the power 3 will give us 8. And 8 times 4 will give us 32. So we have 32. Don't forget we have x plus. Now, you know 2 factorial. You know that 2 factorial is the same as 2 times 1. Okay. You know 3 factorial is the same as 3 times 2 times 1. That is 6. And this is 2. Then you know that 4 factorial is 4 times 3 times 2 times 1. And that is 24. Okay. So here we have 4 here. We have 4 here. 4 minus 1 is 3 here. Then you have 2 raised to the power 4 minus 2 is 2. Then we have x squared. But the 2 factorial is the same as 2. Then plus. Then let's try to simplify this. Here we have 4. 4 minus 1 will give us 3. 4 minus 2 will give us 2 there. Over 3 factorial is the same as 6. And I guess by now you understand. Then we have 2 also raised to the power 4 minus 3 is 1. Then we have x cubed. Now we continue like that. And I guess you understand what is really happening. I guess you understand what is really happening. I just want to separate this from what we are doing. Okay, so then plus, then the next one will be 4. Don't forget, you have 4 minus 1 here. That will give you 3. Then 4 minus 2 here will give you 2. 4 minus 3 here will give you 1. All divided by, don't forget that 4 factorial is the same as 24. So you divide by 24. Then you have 2 raised to the power 4 minus 4. That's 2 raised to the power 0. 2 raised to the power 0 will give you 1. So you are left with x exponent 4. So you will now try to simplify this. So let me get the formula off. If you want to learn how to write the formula, you can get your book, you can get your pen, take the video back and check the formula and try to memorize it. So in simplifying, here we have the 16 here, plus here we have our 32x here. Here we have, this one we simplify. Okay, so we have 4 times 3, and that will give us 12. Now 2 square will also give us, 2 square is 4. Okay, so if 2 square is 4, then you have 4 times 3, that is 12. 12 times 4 will give us 48. But 48 divided by 2 give us 24. So we are going to have 24x squared. Then our next one will be, don't forget that 3 times 2 here will give us 6. So if it's 6 over 6, the 6 is gone. Then we are left with 4 times 2. Because 2 raised to the power 1 is 2. And 4 times 2 will give us 8. So we have 8x cubed. Then we have 8x cubed. Or when you multiply 4 by 3 times 2 times 2, because 2 raised to the power 1 is 2, and you divide by 6, you will still get the same 8. You can try that and see. So we have plus. Now 4 times 3 is 12. 12 times 2, 24. 24 times 1 is still 24. And 24 divided by 24 will give us 1. So we are left with x. We are left with x exponent 4. So this should be the expansion for 2 plus x exponent 4. This should be the expansion for 2 plus x exponent 4 using the binomial theorem a plus s exponent n. Now, if this is the answer we had, I want us to use the constant coefficient and compare the answers whether we are getting the same thing. The constant coefficient. I advise that if you are a little bit confused about what I'm doing here, you only take the video back, take your time, get your book, your pen, and you can pause even the video and look at what I have on the board. So this will be the expansion for 2 plus x exponent 4. Now, don't forget that this 2 plus x exponent 4, the constant coefficient is 1, 4, 6, 4, 1. So assuming we are using this coefficient, we start with the 1. Then 2 will now start with the highest exponent 4. Then our x will start from 0, if you remember. Then we are on the next term 4. Then 2 will decrease from 4 to 3. Then x will increase from 0 to 1. Then we are on the 6. Then 2 will now also decrease from 3 to 2, but the x will increase from 1 to 2. Then we have 4. Then 2 will decrease from 2 to 1, but the x will increase from 2 to 3. Then we have the last coefficient, and 2 will decrease from 1 to 0, and x will increase from 3 to 4. So as the first term is decreasing, the second term is increasing. Okay, so this will be, then we have x, 2 raised to the power 4 is 16. 16 times 1 is 16. And x raised to the power 0 is 1. So 16 times 1 will give us 16. Then we have our first term. Okay, so 2 raised to the power 3 is 8. Then 8 times 4 will give us 32. So we have 32x because x raised to the power 1 is x. Then we have plus. Then 2 square here will give us 4. Then 4 times 6 will give us 24. And 24 times x squared will give us 24x squared. Then we have 2 raised to the power 1 is 2. 2 times 4 is 8. So we have 8x exponent 3. Then plus 2 raised to the power 0 is 1. 1 times 1 is 1. 1 times x raised to the power 4 is x raised to the power 4. And this will be the expansion for 2 plus x exponent 4. So when you compare this and this, realize that we have the same thing. So you have 16 plus 32x plus 24x squared plus 8x cubed plus x4. And that is what we had when you use the binomial expansion. When we use the a plus x exponent n formula, this is the same thing. So when you are trying to use the Pascal approach, you are trying to use the constant coefficient, this is how you solve it. But if you are trying to use the formula, then you can take the video back and compare. You will get the same answer. So if you are asked to use binomial theorem to expand, then you are supposed to use this formula. But you can cross-check with the constant coefficient of the factor theorem, you are getting the same thing. So in general, that is how you apply. So I want to try to put the formula down here. So you look at it. So you have a plus x exponent n is a raised to the power n plus n minus 1 x plus n minus 1 over 2 factorial a n minus 2 x squared. Then we have n, you have n minus 1, you have n minus 2 over 3 factorial a n minus 3 s cubed plus up to x exponent n term. Then, and this is, you use this one, n, or the exponent is a definite positive integer. Then you also have 1 plus x exponent n, and this is 1 plus nx plus n minus 1 over 2 factorial x squared plus n minus 1, you have n minus 2 over 3 factorial s cubed up to the term in x exponent n. So you take note of these are the two formulas you'll be using in the binomial theorem. In our next presentation, you will look at the combination approach. In our next presentation, you also take different questions and see how best you can use the two formulas to solve for that. So in general, that will be all for now on this particular episode. Thank you.